This problem is a challenge, and it will help us preview something that we will learn about in Chapter 5. What I want you to focus on with this problem is making sense of the problem, MP1, being able to write an equation to model it, and focus on using your calculator. Hence, this is the graphing calculator required section. The problem is giving us a cardboard sheet, which we can model with a rectangle. It's 21 inches by 56 inches. A square corner is cut out of each corner, but we don't know what the measure of that square is, so we will represent each of those with x. The resulting length is going to make the length of our box. The resulting width will make the width of our box. And our height is going to be x tall because we're going to use this portion here as our side, which is height x. That tells us that our length is 56 minus our left x and our right x, which is minus 2x. Our width is 21 minus our top x and our bottom x, which is 2x. And our height, like we previously explained, is x. So now we have a diagram that represents the situation. For part B, we are asked to write a formula for the volume. Volume is length times width times height. Our length, as we showed right here, is 56 minus 2x. Our width is 21 minus 2x. And our height is x. If this is the most you understand from the problem, you've mastered the stuff that we expect you to know. The next thing we need to think about is the domain. The domain is all of our possible x values. We know that we need to be able to make two cuts from our box, a top cut and a bottom cut. In order to make two cuts, we would cut directly down the center. That would leave us with a maximum cut of 10.5. Unfortunately, we would have no width to be able to make a box with volume. So we're going to use the parenthesis to model that. Our minimum would be a cut of 0. We really can't have a box if we make no cut because there's nothing to fold, so it cannot include 0, so we use the parenthesis. This domain is going to be very helpful when we plug this into our graphing calculator. Why are we plugging into a graphing calculator? Because part D is asking us to find what cut size will result in a volume of 2,000 inches. So we know that Y, our volume, is 2,000 inches. We also know that y equals 56 minus 2x times 21 minus 2x times x. We're going to use our graphing calculator and type y equals. In y1, we're going to type 2,000 inches, and in y2, we're going to type our formula for volume. When we do that, the point of intersection where the two lines cross is going to give us the cut size that will result in the volume of 2,000 inches. So the next thing I'm going to do is I'm going to hit trace on my graph. I'm going to hit second trace on my graph and hit 5 for the intersect. Where do the two lines intersect? That tells me that I am going to get an intersection point of 2.41 inches. The other intersection point, I'm going to hit second trace to get my calc, hit 5 for intersect. It's going to asking about my first curve, and I'm going to make some kind of guess that on my first curve this is going to be around 7. Hit enter. And on my second curve around 7. And the guess is around 7, and it tells me my other y-intercept is about 7.1, or point of intersection is about 7.1 inches. So there's two cut sizes that will result in 2,000 inches, and we used the graphing calculator to graph both equations and found the 2 points of intersection. A cut of 2.41 inches will make a volume of 2,000, and a cut of 7.1 inches will make 2,000. Remember, it's very important to set your window appropriately on these problems. If you hit the window button, we want our x-min and our x-max to come from the domain. So we're going to set those equal to 0 and 10.5. If we do that and then hit the zoom button and 0 for zoom fit, we get an appropriate window that makes a very nice graph and gets this part of the graph maximized to our window. It's really important for part E, where it's asking us for the maximum. So for part E, we want max volume. We need to make sure our window is set appropriately. So then we're going to hit second, trace again. We're going to go to 4 for maximum. Our left bound is 0. You type in 0 and hit enter. Our right bound is 10.5. You type in 10.5 and hit enter. Our guess, not very important because our window centralizes in the area of the graph we're most interested in, and we hit enter. It tells us then that our maximum is at about 4.6 never-ending inches. So the cut size that's going to give us our maximum volume is 4.6 inches. Remember, we're using our graphing calculator to solve points D and E, and we should be able to do A and B easily, and we should be able to reason through part C.